Have you ever had one of those brilliant light bulb ideas, only to get that sinking feeling, what if someone else claims it first? Well, today we're going to dive into how to solve that exact problem, but for something really important, scientific discovery. We're going to explore a cryptographic system that basically creates unforgeable ideas, and it could totally change how we trust science itself.
Okay, so imagine this. You're a scientist. You've just come up with this wild, groundbreaking prediction, but the experiment to prove it, it's going to take a whole year. So how do you prove to the world that you had this idea today, right now, way before you could possibly know the outcome? How do you stop people from saying you just made it all up after the fact? That's the huge problem we're talking about.
And look, this isn't just some academic thought experiment. This is a real nagging problem in the world of science. When we can't prove exactly when an idea was born, it creates this subtle but really serious crisis of trust that can actually slow down or even undermine progress. The villain in our story even has a name. It's called the file drawer effect. It's this all-too-human tendency for researchers to, quietly file away the experiments that fail or give messy, inconclusive results. They only end up publishing the ones that look like a big, clean win. It's all about showing off the shiny successes and kind of hiding the failures in a drawer. So what happens? Well, you get this totally warped view of reality. We only ever see the wins, not all the losses that it took to get there. This hidden data, plus the massive temptation for researchers to just, tweak their original hypothesis a little bit to better fit the results, it attacks the very foundation of what science is supposed to be, honest and reliable. All right, so how do we fight back against this? How do we build a system we can actually trust? This is where technology steps in, and to understand it, let's meet our first hero, a tool that acts like a superpowered digital public notary. Okay, so the tech behind our notary has this pretty complicated name, ED 25519 asymmetric cryptography. But don't worry about that. You don't need to remember it. All you need to know is that it's like a unique, totally unforgeable digital stamp. It proves, without a shadow of a doubt, who signed a digital document.
So what does this digital stamp actually get you? 3 really important things. First up, authenticity. Only the person with the secret private key could have possibly made the signature, so you know exactly who it came from. Second, non-repudiation. That's just a fancy way of saying you can't turn around later and deny you signed it. And finally, public verifiability. This is huge. Anyone, anywhere can check that the signature is legit without needing any secrets. It's all out in the open.
But, proving who signed something, that's only half the story, right? We also have to prove that the document itself hasn't been changed. And for that, we need our second hero, something that works just like a digital, tamper-proof security seal. So this piece of the puzzle is called HMAC symmetric cryptography. The best way to picture it is like the old-school wax seal on a king's letter, or maybe that security tape you see on a sensitive package. If that seal is broken or looks even a tiny bit different, you know instantly that someone has messed with what's inside. This seal is all about one thing, integrity. It can detect any modification. I mean, no matter how small, we're talking even changing a single comma. It also provides authentication, proving a key holder sealed it. But here's the really important difference from our notary. Its verification is private. You need to have a shared secret key to check if the seal is still intact. Okay, so we've got our notary who proves who you are, and we've got our seal, which proves what you said hasn't been messed with. So why on earth do you need both? Well, it turns out that when it comes to security like this, 2 very different kinds of locks are always better than one. Let's break it down. It's really simple. The notary, that's all about being public. It proves your identity for the whole world to see. The seal, that's private. It proves the integrity of your work, making sure it hasn't been modified. One proves who you are, the other proves what you said. They just perfectly cover each other's blind spots. When you use them together, you create this incredibly powerful security concept called defense in depth. Think about it. To successfully fake a scientific prediction, an attacker couldn't just compromise one system. They would have to defeat the public signature and somehow steal the secret key for the seal. That is an incredibly tough nut to crack. All right, let's put it all together. We have this super robust 2-layer system. So how does it actually fix our original problem? How does it protect the integrity of a scientific prediction out in the real world? So how does this work in practice? Well, it all boils down to a really simple but super powerful process. For any prediction to be considered legitimate, it has to pass a strict 3-step cryptographic check. No ifs, ands, or buts. Step 1, we check the notary. We're verifying that ED 25519 signature. This is all about authenticity. Did this prediction really come from the scientist who says they made it? It's a simple yes or no, pass or fail. Step 2, we check the seal. Using that HMAC code, we're laser-focused on integrity. Has the actual content of the prediction been altered at all since it was sealed? Even one single changed byte will break that seal and the check fails. It's that sensitive. And finally, and honestly, this is the real game changer, we verify the timestamp. This step is all about timing. Was this prediction verifiably made before the experiment was run? This is the one that just completely defeats the file drawer effect, because you can no longer change your story after you already know the answer. The impact here it's just huge, especially in really tough or controversial fields like consciousness research. All of a sudden, researchers can't hide their failed predictions anymore. They can't just tweak their ideas after seeing the data. It creates a system where anyone in the scientific community can verify these claims without having to just trust someone's word for it. Instead, they can trust the math. I mean, to put it as simply as possible, this system makes it cryptographically impossible to modify predictions after verification. Just let that sink in for a second. It's not just a promise of being secure, it's a mathematical guarantee of integrity. So this leaves us with this one big, exciting question. If we can now literally lock in our scientific ideas with cryptographic proof, guaranteeing their authenticity and integrity before we even test them, what does that open up for the future? What bold, controversial, or seemingly impossible questions can science now finally start to explore with total confidence?